This is the video for section 4.4, the method of undetermined coefficients. So in this section, we would like to develop a way that we can solve linear equations with constant coefficients that are non-homogeneous. So here, L of y is our linear differential operator with constant coefficients, and now instead of having an h-lec, we have an n-h-lec, so a non-homogeneous version. And this method, the method of undetermined coefficients, it's going to work when g of x is either a constant, a polynomial, an exponential, a sine or cosine function, or some linear combination of any of these. And sort of the reason behind this is that when you take derivatives of those particular functions, you get another function that is in that set. So if I take the derivative of an exponential, I get an exponential. If I take the derivative of cosine, I get sine, etc. So we're going to see how this method works and why it's sort of restricted to this class of functions. So here's the key. We're going to assume that our particular solution has the same form as g of x. So let's solve y double prime plus y prime minus 6y equals 2x. And to do this, we have to remember all that we've learned about how to solve non-homogeneous differential equations. So the first step is we need to solve the corresponding homogeneous equation. We need to solve the h-lec, y double prime plus y prime minus 6y equals 0. And I'll assume that you are experts with that by now, and you get that your complementary solution, remember that's what we called it, is equal to c1 e to the minus 3x plus c2 e to the 2x. So we have to start there, and now to solve the non-homogeneous differential equation, we need to find a particular solution to the non-homogeneous case. So the method of undetermined coefficients says, okay, let's assume that our particular solution has the same form as g of x, which in this case is linear 2x. So we're going to assume that y sub p is ax plus b. And then we're going to see what happens when we plug that into the differential equation. So if y sub p is ax plus b, yp prime is a, yp double prime is 0, and we plug that into the ODE, and we get 0 plus a minus 6 times the quantity ax plus b equals 2x. So I can do some algebra here, and I get negative 6 times a times x plus a minus 6b equals 2x. So the first piece, I can separate this into two equations. And the first piece tells me that negative 6a equals 2, which means a equals negative 1/3. And then also, a minus 6b must be equal to 0. So negative 1/3 minus 6b equals 0, which means b equals negative 1/18. So that tells me that my particular solution is negative 1/3 x minus 1/18. And you should check that that is indeed a solution to the non-homogeneous differential equation. So my final step is to write the general solution, which is the complementary solution plus a particular solution. So in this case, that is c1 e to the minus 3x plus c2 e to the 2x minus 1/3 x minus 1/18. So the method of undetermined coefficients, it's basically sort of making an observation of what works for our, what's going to work for our particular solution. So you have to make an educated guess. And here's sort of the guidelines of how you should guess what your particular solution is going to look like or what form it's going to have. There's two cases. Case 1, no function in what you want to assume your y sub p is also a solution to your homogeneous differential equation. In that case, your guess for your particular solution is going to be a linear combination of all linearly independent functions that are generated by repeated differentiation of g of x. So let's see an example of how that works. And I should say the previous example was also an example of this case. So let's see an additional example of how this works. So I have the non-homogeneous linear differential equation, y double prime plus y prime minus 2y equals cosine of x. Step 1, solve the corresponding HLEC. I'll assume you can do that, and you get that the complementary solution is c1 e to the x plus c2 e to the minus 2x. Now, using the method of undetermined coefficients, I want to make a guess that my particular solution is a linear combination of g of x and all of its derivatives. So the only new linearly independent function I get when I differentiate cosine repeatedly is sine. So I'm going to assume that y sub p is a times cosine x plus b times sine x. Neither of those solve the corresponding HLEC, so I'm all good. I just continue on. Yp prime is negative a sine x plus b cosine x. Yp double prime is negative a cosine x minus b sine x. And now I plug that into the differential equation. And I get negative a cosine x minus b sine x plus negative a sine x plus b cosine x minus 2 times a cosine x plus b sine x equals cosine x. And I can clean this up a little bit. I get negative a plus b minus 2a cosine x plus negative b minus a minus 2b sine x equals cosine x. Clean it up a little more. Negative 3a plus b times cosine x plus negative a minus 3b sine x equals cosine x. So now I set coefficients equal. Negative 3a plus b must equal 1, and negative a minus 3b equals 0. And the second one of those equations tells me that negative 3b equals a. So then I do substitution to solve for b, and I see that in fact b equals negative 1/8, which means a equals negative 3 times negative 1/8, or 3/8. So that tells me that my particular solution is 3/8 cosine x minus 1/8 sine x. And my final step is the general solution is given by my complementary solution plus my particular solution. So c1 e to the x plus c2 e to the minus 2x plus 3/8 cosine x minus 1/8 sine x. So case 2 is when a function in your desired guess for y sub p is also a solution of the corresponding homogeneous equation. And in that case, you want to multiply your desired particular solution, or your desired guess, by x to the n, where n is the smallest integer that removes the duplication. So let's see an example of that. Let's let y double prime minus 6y equal e to the 4x. First step, solve the HLEC. We get our complementary solution is c1 e to the 4x plus c2 e to the minus 4x. And the guess we would like to make with the method of undetermined coefficients is that our particular solution is a times e to the 4x. But that is also a term in our complementary solution. So if we let that be our particular solution, we wouldn't get any more information. We would still be missing a particular solution that is not encompassed by the complementary solution that we already have. So the method of undetermined coefficients says guess that y sub p equals a times x to the n e to the 4x, where n is the smallest integer that removes the duplication, which in this case n is just equal to 1. So guess that your particular solution is ax e to the 4x. That means yp prime is a e to the 4x plus 4ax e to the 4x. And after a little bit of algebra, you can show that yp double prime is 8a e to the 4x plus 16ax e to the 4x. Now if we plug those into the ODE, we get 16ax e to the 4x plus 8a e to the 4x minus 16 times ax e to the 4x equals e to the 4x. So 8a e to the 4x equals e to the 4x. 8a equals 1, a equals 1/8. So my particular solution is 1/8 x times e to the 4x. Then we finish the problem, as always, writing the general solution, which is y equals c1 e to the 4x plus c2 e to the minus 4x plus 1/8 x e to the 4x. So in class, we'll do some more problems and examples, but these are sort of the two main cases that will guide you through how you guess your particular solution when you use the method of undetermined coefficients.